This video is on writing very large numbers in scientific notation. So, if we look at the number 25 million, that is a very large number, an example of one. And there are lots of different, well, this would be annoying to write sometimes. We might like to shorten it. So let's think about how we can use a different notation called scientific notation, how to shorten this. So there are two parts of scientific notation. The first is called the mantissa. So in this case, 2.5 is the mantissa. The mantissa is always a number between 1 and 10. So always one in the ones place here, followed by some things in the decimal values, multiplied by a power of 10. So in this case, we use a power of 10, which will be something to a certain power, which we're getting to there, because we work in a base 10 number system. And that means that once our ones fill up, we go to tens, hundreds, thousands, etc. So 2.5 is our mantissa because when we just look at those first few numbers right there, we have the number between 1 and 10 of 2.5. So if we take the number 2.5 and multiply it by 10, we get 25. If we take the number 2.5 and multiply it by 100, we get the number 250. If we take the number 2.5 and multiply it by 1,000, we get the number 2,500. If we take 2.5 and multiply it by the number 10,000, we get 25,000. If we take the number 2.5 and multiply it by 100,000, we get the number 250,000, and so on. Okay? We could continue this pattern all the way until we get to 25 million. So let's look at more patterns that are going on here, okay? 10 is the power of 10, 1 to the first power, just 10. 100, we know, is the same as 10 times 10, or 10 squared. 1,000, we know, is the same as 10 times 10 times 10, or 10 to the third power. 10,000 would be 10 to the fourth power. 100,000 is 10 to the fifth power. So this was getting pretty long for me to write. So I'm going to write it in this shortened version. So if I continue with my pattern here, 2.5 times 10 to the sixth will get me 2,500,000. And 2.5 finally times 10 to the seventh will give me 25 million. Okay, so this is to show you how we get 2.5 times 10 to the seventh power, no longer a question mark anymore. That is how we can rewrite this number in scientific notation, 2.5 times 10 to the seventh power. In your calculators, a lot of times you'll see it as 2.5e7. Okay, that's how it looks in your calculators sometimes. So this is a lot of work where essentially what we want to do is start at 2.5 and figure out how many place values we need to multiply this by. Here we multiply by 1 place value, 2 place values, 3 place values because of our base 10 number system, power of 10 here. Okay, so you can go through all of these steps right here to do this, or you can take the number, we'll use 25 million again, and you can do like this, okay? You can take your first values there All right, since this is just 25, I'm going to make this 2.5 in order to figure out how many place values I'm going to need to multiply by mantissa by 10 to what power. I'm going to count the place values. 1, 2, 3, 4, 5, 6, 7. So it took me 7 place values to get back to my original number. So whether or not this you do all this out, you can see the connection here of using place values to count our number into scientific notation. One more example that I want to give you is if you have something like the number 372,462. Okay, this is a big number, and there's a whole lot of numbers here, so we're going to estimate this. You can take either the first 2 or 3 numbers in order to find your mantissa. In this case, I'm going to take the first 3. So I know it's has to be a number between 1 and 10, so I'm going to make this number 3.7, and I'm going to look at the number next door. It doesn't need to be rounded up. 3.72 times 10 to a certain power. Well, how many place values do I need to get back to my original number? I need 1, 2, 3, 4, 5 place values to get back. So to rewrite the number 372,462, I can write it in scientific notation as 3.72 times 10 to the 5th power.